When you think about the Nordic countries, you probably picture these beautiful, calm fjords, maybe some ancient, quiet mountains. But what if I told you there's also this incredible, violent power just bubbling right under the surface? Well, today we're going to dig into the epic forces of fire and ice that actually sculpted this amazing landscape. It kind of seems like a contradiction, doesn't it? How can one region be a land of both explosive fire and ancient ice? I mean, home to volcanoes that blow their tops, but also covered in mountains carved out by glaciers? That is the exact puzzle we're going to solve today. And, the answer is hiding deep, deep down in the Earth's crust. And this right here perfectly captures those two giant forces at play. On the one hand, you've got a volcano erupting. That's where the Earth literally cracks open and super hot magma bursts out as lava. And on the other hand, you have a totally different kind of pressure, where two massive plates are crashing into each other, folding the Earth upwards to build mountains. Pulling apart and pushing together, that's the key to all of this. Okay, first up, let's talk about the fire part of this whole equation. To really get a handle on the explosive power of a volcano, we got to start by looking way down deep beneath our feet. It all kicks off with magma. Just imagine this super hot melted rock churning around inside the Earth. Now, the second it breaks through the surface and erupts, poof, its name changes to lava. And this isn't just a science class detail. As that lava hits the air, it starts to cool down, harden, and build brand new land right in front of us. So the birth of a volcano, it basically happens in 3 steps. First, a crack or some kind of weak spot opens up in the ground. Then, because of all this incredible heat and pressure from below, magma starts pushing its way up through that crack. And finally, you get the big show, the eruption of lava, smoke and ash that, over time, builds up that classic volcano cone shape. Okay, but hold on. If there's magma under the entire planet, why aren't there volcanoes popping up everywhere? Well, the answer is that the Earth's crust isn't one solid shell. It's actually more like a giant puzzle made of these massive, moving pieces we call tectonic plates. And that brings us to Iceland, which is basically geology's superstar. Just look at this map. The island is literally being torn in two. It sits right on top of the Mid-Atlantic Ridge, which is the boundary where the North American and Eurasian plates are pulling away from each other. That crack is the perfect escape route for magma to come bubbling up. This really makes it clear, doesn't it? On one side, you've got a place like Iceland, sitting right on a plate boundary, a weak spot where magma can easily get to the surface. So, volcanoes? Yes. But then you have a place like Sweden, which is sitting safely right in the middle of a plate, far away from all that action. So volcanoes? Nope. It's all about location, location, location. Now, let's just zoom out for a second and look at the whole planet. This map shows you all the major tectonic plates. You can see how these boundaries snake all across the globe, creating these zones of intense action, like the famous Ring of Fire around the Pacific Ocean. Iceland's spot on the Mid-Atlantic Ridge is just a really powerful and really clear example of this process. So we've seen what happens when plates pull apart. But what about when they do the complete opposite? What happens when these giant forces reverse and the plates collide head-on? Well, that's how we get mountains. I mean, this process is just mind-blowing. Instead of cracking open, 2 plates smash into each other. The force of that collision is so huge that the crust has nowhere to go but up. It just squeezes and folds, kind of like a rug you push from both ends, creating these massive mountain ranges over millions and millions of years. And this incredible mountain building process has shaped the entire Nordic region. But there is one country in particular that really owes its dramatic, world-famous landscape to this exact geological force. Any guesses which one it is? If you guessed Norway, you are absolutely right. The Scandinavian mountains, which basically form the backbone of the country, are what's left of an ancient collision between continents that happened over 400 million years ago. So the huge peaks and deep fjords we see today, they're the direct result of that continental fender bender. Okay, on to our third feature, geysers. This is where fire and water meet in a really spectacular way, and it all ties back to that underground magma we were talking about earlier. So what is a geyser, really? Well, you can think of it as a hot spring with a bit of a plumbing problem. Instead of the heat just escaping gently, pressure builds up and up in this network of underground cracks until it just can't be contained anymore, and it results in this huge eruption of superheated water and steam. The recipe for a geyser is actually pretty simple. First, you have rainwater seeping deep down into the ground, filling up all these underground pockets. Second,
You have a nearby magma chamber that acts like a giant stove, heating that trapped water way past its normal boiling point. The pressure builds and builds until, boom, it finds a way out and erupts straight into the sky.
And of course, people have figured out how to use this. This geothermal activity isn't just amazing to look at, it's a huge source of clean energy for Iceland. And, on a more relaxing note, it creates these natural wonders, like the famous Blue Lagoon, which is a perfect example of geology you can actually swim in. All right, we have covered a lot of ground here, from magma deep inside the earth to mountains that touch the sky. So let's do a quick recap to make sure all these ideas about fire and ice are locked in. Let's put that new geological know-how to the test. I've got a few quick questions just to see what you remember. Ready? First one up, what do we call that molten rock deep inside the planet? Give you a second. The answer is magma. And remember, it only turns into lava once it gets to the surface. Question number 2. When those tectonic plates crack and start pulling away from each other, what's the big geological feature that can form in that gap? That's right. That's how volcanoes are born. Next question. What about the opposite? When the plates crash into each other with all that incredible force? Yep, that process is what builds mountains. And for the final question, when water gets superheated by magma way underground and then erupts in a huge blast of steam, what do we call that? That would be a geyser. So, how did you do? So, I guess the big takeaway here is that the ground beneath our feet isn't just solid and still. It's this dynamic, living system. The incredible landscapes we see in the Nordic region are proof of these powerful forces that are always at work. And it really makes you wonder, doesn't it? If this is what millions of years have already created, what kind of new wonders will these forces of fire and ice build in the next million years?